Okay, so today what we're going to be doing is solving trigonometric equations, and in order to do this, we are going to need to evaluate the inverse trigonometric functions. Let's talk about the word inverses. We have seen inverse functions before in this classes. So recall situations such as this where we have x cubed equals 5. This is a cubic function. And recall that the way that we solved this is we took the cube root of both sides, which would give us x equals the cube root of 5. So that is, the cube root functions are inverses of the cubic functions. Because the trigonometric functions are periodic, a trigonometric equation like sine theta equals 0 has infinitely many solutions. And if you think of the fact that if you have a graph of sine, and it looks something like this, here, 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 all solutions. Those are all places where sine theta equals 0. So you see how, like, you have infinitely many solutions because this graph goes infinitely to the left and infinitely to the right. So it would have infinitely many solutions. But an inverse function really can only have one solution. So we're going to talk about some graphs of these. Fortunately for you, you don't have to graph these. I'm just showing you what the graphs are. So to solve trigonometric equations, you can use an inverse trigonometric function to find one solution. Then you can use periodicity to find all solutions. Since a function must be single-valued, you define the inverse function for each sine, cosine, and tangent by inverting only the representative part that has the simplest domain values. So hang on for a second here. I want you to see what one of these looks like. If you take the function y equals cosine x, here is the inverse function. Theta equals inverse cosine x. That's how you say it, inverse cosine. All right? And do you remember when we were finding inverse functions, you switch x and y, and then you solve for the new y? And that would get, that's what this is. Because if you switch theta and, well, you'd have to switch theta and y, because that's really what you're switching. But that's how you do this. I mean, it's easy when you have a line to do things like that, but it's not easy when you have a trigonometric function. So we define a new function to be the inverse. So here's the function y equals sine theta. The inverse function, theta equals inverse sine of x. All right? Here's another one, y equals tangent theta. Inverse function, theta equals inverse tangent of x. All right? What I want us to do is turn the page here and let's take a look at these graphs. This is y equals cosine theta. And what you see is that the representative part of the function goes from here, travels along here, and ends here. And the reason why we say this is the representative part is because this part has an inverse. Because remember, when you take the inverse of a function, you can't have the situation where you have multiple y values for the same x value. So notice something about this. The domain of this goes from 0 to pi, right? So the domain is from 0 to pi. And what's the range? From -1 to 1, right? Okay, When you go over and look at the inverse function, here's this. Now, what was the range is the domain. So the domain goes from -1 to 1. And the range goes from 0 to pi. Because remember, the range and the domain switch places when you find the inverse. Okay? We could do the same thing. Here's the sine function. We could do the same thing. Here is the tangent function. Same thing. All right? Here's the issue. You're not going to have to graph any of these. I just want you to see that these inverse trig functions have graphs. You know, let's talk about this for a minute. Let's move this down here. We're going to write it. No, the last page was a good place to write it. All right. Take this as an example. Just so you are aware, if this shows up on an ACT or an SAT somewhere, there is another way to write this same exact thing, and that is arc cosine, which looks like this. Okay? So instead of cosine with the little -1 as an exponent, and that means inverse cosine, we have arc cosine. Means the same thing. So if you see this notation, all I want you to be aware of is it means this. We are going to use this notation. Now, on your calculator, there are keys for this. We will get to those. All right, but note that these are the same thing. So inverse sine, inverse tangent, arctan. All right, it's a thing. But here's what we're going to do. When we look, and let's go down here, we're going to use the unit circle. So get this guy out here and get him ready. All right, we're going to evaluate values for inverse cosine, inverse tangent, and tangent. And the way that we're going to do that is we're going to use our unit circle. So here's what this is asking you for. All right? When we say, what is the inverse cosine of 1/2? All right? It means I want you to tell me what angle gives you a cosine value of 1/2. All right, so instead of before where we went to an angle measure and we looked at the x value, what you're going to do, it's cosine, so you're going to go to the x value and you got to look for 1/2. So as an x value, here's 1/2. So we have pi over 3, right? Awesome sauce. Okay, so that's what we're going to start with. We are going to start with pi over 3, which is also 60 degrees. Okay? Now, would you agree we could also do this one down here? Really? There's multiple. And if I keep going around, I'm going to keep hitting it again. Right now, we're going to focus on here. All right? Inverse cosine. Why did I write the same one twice? I don't know. Let's skip it. Inverse sine 1/2 in degrees. So you go to your unit circle. I'll put it up here. What's inverse sine 1/2? 30 degrees right here. So you see the y value is 1/2, so 30 pi over 6. Now, if you have memorized your unit circle, you have already made your life so much easier. Whoops. What is inverse tangent of 1? Now, this is trickier. tangent is y over x, right? And if tangent equals 1, what must be true about x and y?
They're the same. 45 degrees.
It is 45 degrees. Why? Because they're the same. To get an inverse tangent of 1, your x and your y value must be the same thing. And you need to look at where they're the same. They're the same here. They're the same over here. Those are the only places that they are the same. All right? So pi over 4, 45 degrees. So tangent, not quite as easy. I'm going to flip the page. Is that okay?
Yeah, I'm sitting at the top right stuff.
Can I give it to you later so that we don't all sit here and record for... Okay. Okay. We're going to use our calculator a little bit. And it says, what are the radian measures of all angles whose sine is negative 0.9? So solve using an inverse function, a calculator, and the unit circle. All right? So here's this is the unit circle right here. We have this drawn. And it is going to be helpful for us. So what we're looking for is sine inverse negative 0.9. What are the radian measures of all angles whose sine is negative 0.9? There we go. Theta. Okay. Now, what you want to do is draw those 2 points that happen to have a y value, because remember, sine is y, of negative 0.9. So here's one, y value, negative 0.9. Here's another one. We don't know what the x values are. At this point, it really doesn't matter. All we know is there's an angle measure right here, and there's an angle right here. And the issue is we kind of want to capture different ways that we could write these. One is going to be going this way from here to here. Another way is going this way from here to here. All right? So, let's go ahead. We're going to need our calculator in radian measures. So, remember, go to your mode. Make sure you're in radian measure. Quit to get away from that screen. Clear to get the last class's crap off your screen. And let's look for that inverse sine key. And you'll see that it is a second sine key. All right? So second inverse sine negative 0.9. And I've got negative 1.12 radians. Does that sound reasonable? Okay. So theta could equal negative 1 point, what did I say? 12 radians. Where is that? That's here. Agree? Okay. So we've got that. We have to get the other guy. So first of all, if we say that this is an angle measure, you realize every time you go around 2 pi radians, you're going to get another one, right? So we would say negative 1.12 plus 2 pi n. And n is just any number. So it represents all the different times around that you can go. You are always going to add this to the end, because we could go around 2 pi, 2 pi, 2 pi, 2 pi, 2 pi. 2 pi times 1, 2 pi times 2, 2 pi times 3, 2 pi times 4. We could keep going around n times and get more angle measures in radians. Let's see. We want to take a look at when we have an angle measure down here and down here. And do you see how they have the same, we were doing sine, y value down here? These are related somehow. How are they related? Would you agree that this amount right here is the same as this amount right here? Okay. So, and we need to get this guy right here. Would you agree? So can I get you to agree that this, if this is 1.12, that this right here is pi plus 1.12? Okay, because we just need to find him. So we've got pi plus 1.12, and we're going to go to our calculator, and we have a lovely pi key to help us out. Pi plus 1.12, 4.26, fair enough? Equals 4.26. So now we have 4.26, plus we can go around n number of times. So I have this as an answer, and I have this as an answer. And I will tell you, if I don't draw this circle so I can visually see where my second answer is and mathematically figure out how to get there to it, because the calculator is only going to give you the one. It's not going to give you two. All right? So let's try another one. And this time I left it blank, so we're going to draw our unit circle. What are the radian measures of all angles whose sine is 0.44? So I am looking for theta equals sine inverse 0.44. All right, and I'm going to draw a really rough circle because I think I put my circle maker in my bag, and goodness only knows where that is going. Yeah, I think circle maker could be anywhere at this point. Yeah, missing in action. That's a really lovely circle. So would you agree? 0.44 is maybe somewhere right around here? So this is x1, 0.44, and this is x2, 0.44. Agree? And I know because this is 1 right here, guys. This is 1. So 0.44 is like halfway between that. That's how I know that's where that is. All right, let's see which one of these we actually get. So I'm going to put in here inverse sine 0.44, and let's see what I get. So I get 0.46. That's going to be this guy right here. So theta equals 0.46 plus 2 pi n. So there's one answer. And that's this guy right here. We'll put a little mark there. 0.46. How do I get this one?
2 pi plus 20.
Go based off of pi. This is pi over here, because isn't this thing the same as this over here? But how about minus? Because you're going like this. So this is pi minus 0.46. It's less than pi. Would you agree? That's how you know you're going to subtract it, because you didn't get all the way around here to pi. So it's pi minus 0.46. So theta equals pi minus 0.46, 2.68. So 2.68 plus 2 pi n. That's infinitely many of them. All right?
Wait, how did you find the first 0.46 again?
Put it in my calculator. Put this in my calculator.
Okay.
That's all good. Okay, let's go ahead and do example 3 down here at the bottom of the page. This works a little bit differently. It says, what are the radian measures of all angles whose tangent is negative 0.84? Solve using an inverse function, a calculator, and a unit circle. So we want theta equals inverse tangent negative 0.84. Now, to get a negative tangent value, wouldn't you agree the x and the y have to have opposite signs? Because it's y over x. So one is positive, one's negative. So it's either down here or down here. And in fact, would you agree it's going to be in both? Okay? It is. So what you're going to do is you're going to find the one that we got here. And we can do that in our calculator. Let's move our calculator there so we got some room. And we're going to do inverse tangent. There we go, inverse tangent, negative 0.84, close the parentheses, and I get negative 0.70. Does that seem reasonable? Okay. Okay, here's the thing that's a little bit different. That match point in the other side is going to be on that same line. So guess what? It's pi distance away, because pi is a half of a circle, right? So that's how far away it is. So 0.70 plus pi n. And if you want to get this guy, all you got to do is you can either, well, to get this right here, it's pi minus, because this part is the same as this part. So pi minus 0.7. All right. So if I wanted to get that one, let's put them in there. Pi minus 0.7 would be 2.44, but we don't need him. This is sufficient with tangent. All right, you might see in your answer solutions, they might have the other one too, which is 2.44. You don't need him. This is sufficient. All right. Busy, busy day. Now we are finally to the point where we are going to solve trigonometric equations. Okay. Oops, let's get it on the screen there. For what values of theta, where theta is between 0 and 2 pi, satisfy the equation 4 cosine theta minus 1 equals cosine theta? All right, bear with me. We're going to take this equation, and what I want you to do out of this is isolate cosine theta. All right, so how about this? Subtract 4 cosine theta on both sides. Simple algebra. And then you have negative 1 equals negative 3 cosine theta. So we all follow so far? You need to get cosine theta by itself. So divide by negative 3 on both sides. And would you agree, you get cosine theta equals 1/3. Right? Okay, we're doing good. We are doing good. What you do at this point is switch it to an inverse cosine equation. So when we do that, this is theta equals inverse cosine 1/3. All right, we can get this on our calculator, and let's do our little unit circle thing. and it's a very horrible circle since I lost my little circle maker. My x value is 1/3, positive 1/3, so maybe right about here and about here, all right, are going to be my two angles. That's where the x value equals 1/3. All right, because this is 1 right here, so this is about 1/3. All right, so that's how I set that. Let's go to our calculator, and we're going to do inverse cosine 1 divided by 3. Get our fraction in there, and we get 1.23. Okay? So we get theta equals 1.23. Which one of these is 1.23, the top one or the bottom one? The top one. So this up here is 1.23. How do I get this guy? Subtract what?
5 from 1.23. 3 pi. 2 pi.
Would you, can I get you to agree that this right here is a negative 1.23? Okay. Right? So how about 2 pi minus 1.23? So theta equals 2 pi minus 1.23. Let's get that on our calculator. So, whoops, 2 pi minus 1.23, 5.05. There we go.
How do you know it was 2 pi again?
Well, a full rotation is 2 pi, right? It's this much short of a full rotation. So that's why I'm subtracting that amount. Okay. Let's do another one. What values for theta, where theta is between 0 and 2 pi, satisfy the equation 3 sine theta plus 1 equals sine theta? Let's take a different approach to this. How about subtract sine theta? And I've got 2 sine theta plus 1 equals 0. And let's move the 1 to the other side. So I've got 2 sine theta equals negative 1, right? Divide both sides by 2. And I have sine theta equals negative 1/2. So this is theta equals inverse sine negative 1/2. Do you think we need our calculator, or could we actually do this on our unit circle? Would this value show up on our unit circle? Yes, it would. You should recognize that value, negative 1/2. So if you go here looking for a y value of negative 1/2, here is a y value of negative 1/2, and, or I'm sorry, right here and right here, y values of negative 1/2. So guess what your answers are? 7 pi over 6 and 11 pi over 6. That's it. You didn't need your calculator. So we have theta equals 7 pi over 6, theta equals 11 pi over 6. Okay, we have one more example to do, and it is a doozy. Okay? You're going to use all your algebra skills to solve trigonometric equations. Take a look at this one. Fair enough? All right.
Oh my god.
Here's what you can do with this. We can factor. Do you realize that we have 0 on one side, right? So zero product property is something we can use, and we can factor out a sine theta, right? Okay, so here's what I would have. I would have sine theta, and in parentheses, 2 cosine theta plus 1 equals 0. And would you agree? If I were to do distribution, I would get my original equation. Agree? Okay, so now zero product property. This times this equals 0. So therefore, this is 0 or this is 0. So I have this, sine theta equals 0, and this one, 2 cosine theta plus 1 equals 0. So here, what I'm looking for is theta equals inverse sine of 0. So we'll solve that in a second. And over here, subtract 1 on both sides, and I get 2 cosine theta equals negative 1. Divide both sides by 2, and I get cosine theta equals negative 1/2. So far, so good. Switch this to your inverse. So theta equals inverse cosine negative 1/2. This should give us 2 answers, and this should give us 2 answers. So right here, you can use your unit circle for this. We need to look for what being 0? Y, all right? So where is y 0? Pi and 2 pi. So actually 0 pi and 2 pi. We can put all of them. So theta equals 0. Theta equals pi. Theta equals 2 pi. Because it does ask for all of them between 0 and 2 pi, and it includes 0 and 2 pi. Now, can we find this on our unit circle? Inverse cosine negative 1/2. What are we looking for to be negative 1/2? X, because cosine is x. So where is our x value negative 1/2? So, up, you're right there and right here, x. So 2 pi over 3 and 4 pi over 3. Fair enough? All right. So theta equals 2 pi over 3. Theta equals 4 pi over 3. So if you can use your unit circle, use your unit circle. All right? If you can't, you can go to your calculator. But you will have some you can use your unit circle on. You have to look, you know what numbers to look for. These are your golden numbers right here. 0, 1, 1/2, square root of 2 over 2, and square root of 3 over 2. If you have any of those, you can do them. Anything else, you're going to have to use your calculator.